Okay, so what we're going to do now is we're going to look at part C. So it says, again, we'll highlight the main points. So it says, in elevation, so we're talking about this view, the focus of the parabola, ABC, so my curve here, is 4.9 meters from the vertex B. So basically 4.9 meters this way. Now, I suppose if we weren't sure of the question, we might think it's 4.9 meters the other way, but the vertex would have to be inside in the parabola. So, oh no, sorry, yes, from the vertex. So this is our turning point. So sorry, the focus would have to be inside the parabola. So locate the focus and draw a line which is tangential to the parabola at point C. So this is my point that I need. So the first thing says locate the focus. So again, simple marks, more than likely for getting that. So we will take our question here. We know it's 4.9 meters and we know the scale is 1:100, so that's 49 millimeters. So there we go. So that's part, I would call it F for our focus, and this is point C. Right? So straight away we've got something for that because it asks us to do that. Now, I suppose for a lot of us we may not know how to do this, but we do know that we want a tangent here. So the first thing we want to do is, if we're not sure what to do, we're basically going to draw in a line there, right? But the second thing we think about is, well, what might be useful construction even if we're not sure how to do it. So I'll take a blue here and we'll highlight in. Typically, if you're ever unsure, join the point that they talked about to the bit that you found. So we found the focus and to talk about point C. So we join the two of them together. And we're going to look again, we're going to say, well, our line for it to be tangential would have to look to be 1 point. So it's going to be something like that, right? So we just lightly join a line there. I don't know if that's seeable. Right? So I'm just going to draw that very lightly here. Hopefully we can see that there. So if we look at that and then we look for, well, maybe how could they have done this? That angle there looks to be roughly the same as that angle there. So it is probable that they bisected that if we weren't sure. And that's technically our method. So again, what we'd have to remember is going back to our short questions. Typically what we'd have is we'd have a directrix here. So because the ratio is 1:1, this distance here would be the same above that for to put in a directrix. Unfortunately, we can't. And if we were then to construct our parabola using that method, right? So we would take the same, being the same distance for every single one of these points. This distance here is the same distance as the directrix that's above us. That would give us the idea in terms of how to use the tangent. So this would be the same thing here. This would be the line that would go to the directrix, and that line there up to the directrix would be the same as this distance here. Right? So what we'll do anyways is that gives us our hint if we weren't sure how to do it, we hadn't learned off our rules. So what we'll do is we bisect this angle and see, does it work out like we expect it? So there's my 2 points. I'm going to bisect that. Now my initial line might be a little bit off, but by pure estimate it's pretty much bang on. What I'll do is I'll take my red pencil and I'll highlight it. And that's it there basically. So now we've got our line which is tangential to the parabola at point C, we've located our vertex and we've shown our method. Okay, so that's a method to learn off, but again we could have a good idea of how to do it if we look carefully at the question.